Okay, this is Danny doing the probability homework 5 problem 2. First part asks, given f of x of y is 1 over a x squared y, draw the non-zero definition region. And this is what the graph looks like. Because this equation is only defined for positive values, basically it looks like a piece of paper that is flipped at the edge, and the edge keeps going in the z direction. So it's sort of like this. I can't really draw it, but it's supposed to keep going in the z direction like this. Alright, so for part 2, it says find a, so f of x and y is a valid joint density function. All you do is do the integral and set it equal to 1 and find a. So the limits for this double integral is here, is from this condition, or these two conditions. So when you write it out, it looks like this. 1 to infinity for x, 1 over x to x for y, and when you do this whole thing out, let's see. When you plug the values in, you would get negative 2 array times 0 minus 1 equals 1. And then you find that a is equal to 2. So for the third part, it asks to find and draw the marginal density functions f of y and f of x. What you do here is when you find f of x, you use dy, and you do it from 1 over x to x, and that's the balance from y. When you solve this integral, it should look like this. And that's f of x, marginal density. F of y, when you do the integral, you use the bounds of x, and you do it with respect to x. So it's the same integral. Let's see. you ultimately find this to be 1 over 2y, and that's f of y. When you graph this, you can only graph the positive values, so f of x looks something like this. This is f of x, and then f of y just looks like this. So that's what the two marginal densities look like. And then for part 4, you have to verify that they're valid density functions. So that means you have to set them, when you do the integral, it has to equal 1. Yeah. So for f of x, ln of x over x squared, you have to do integral from 1 to infinity of this, and then you find that this to be 1. So this is a valid density function. F of y, you have to split it up. You have to do it over 2 limits. So for the first one is 0 from 0 to 1, and for the second one it's from 1 to infinity. So then f of y from 1 over y to infinity of the same equation, and you find this to be 1 over 2. For the second limit, for second bound, you find this to be 1 over 2 squared.